day 4, we had a Dr.C.Y.Seemikeri sir, head of Mechanical Engineering Department, Government Polytechnic, Nashik, with us. Sir is going to interact with all of us on surface enhancement technology. So on behalf of K.K.Wagh Education Society, K.K.Wagh Polytechnic, Nashik, and Department of Mechanical Engineering, I heartily welcome today's speaker, Dr. C.Y.Seemikeri sir. Now, I would like to hand over session to Professor Sanap sir, head Mechanical Engineering Department, K.K.Wagh Polytechnic, Chandori, to introduce our department and the college. Over to Sanap sir.
Thank you, Lande sir. Good morning, one and all. It's my privilege to give information about K.K.Wagh Education Society. K.K.Wagh Education Society is a leading educational trust in Nashik district. It was established in 1970 by the visionary leader, late Padma Shri Karmavir K.K.Wagh. K.K.Wagh Education Society is the premier educational institute in Nashik district. A small sapling planted by Karmavir K.K.Wagh has grown into a full tree with 31 institutes having over 20,000 students engaged in studies from KG to PhD in various fields. There are over 1,800 dedicated employees following the Indian ethics and striving hard towards perfection and excellence. Now I would like to share the information of K.K.Wagh Polytechnic Nashik. This is the premier technical institute established by K.K.Wagh Education Society in the year 1983. In the successful journey of 37 years, it has maintained the excellent track record in all the fields. To fulfill the growing need of the society, the institute has started its second ship. Professor P.T. Kadve, along with dedicated team of qualified teaching and supporting staff members, works hard to achieve the center of excellence in technical field to bring out cultured human beings. The institute has fully equipped laboratories and amenities. The institute awarded with the Narsi Monje IST Award to Best Polytechnic in Maharashtra. The National Board of Accreditation has accredited the institution in 2004 and 2020. The endorse of having good industry institute relationship were appreciated for 2 years in a row of by AICT and CI by conferring platinum category in their survey 2016-17 and 2019. K.K.Wagh Polytechnic is the only polytechnic to receive platinum category in 2019 in Maharashtra state. This institute is constitute in getting excellent grade in every academic monitoring by Maharashtra State Board of Technical Education, Mumbai. Now, I would like to share some silent features of our K.K.Wagh Polytechnic Nashik. 37 years of wide experience in technical education. We are having a good infrastructure, advanced language laboratory facility is there, then excellent academic result, mentor scheme for individual attention, student-centric education is there. We have a qualified and experienced staff. Then conductive academic atmosphere is there. Availability of e-resources for students on ERP. Spacious playground with tennis, volleyball, and basketball courts. Excellent gymnasium is there. Good industry interaction. Then regular industrial visits are there. Active institute industry partnership cell. Encouragement to students to participate in national and state level competition. Now I would like to say that, or I am very happy to share, our students have filed 2 patents till date. Now our institute receive grants from AICT as well as from DST. Then we are having a good connectivity with all parts of the city by college and city buses. In campus, hostel and mess facilities for the outstation students. TOEFL test center by ET and USA. training in mechatronics and automation in collaboration with Strama Sumit and Nashik. So these are the some silent features of our Polytechnic Nashik. Thank you very much. Now I would like to take the charge, Professor Lande.
Thank you very much, sir, for a wonderful introduction. Now, I would like to request Professor Y.B. Gayadhani, sir, Coordinator, Second Shift, Department of Mechanical Engineering, K.K.Wagh, Polytechnic, Nashik, to introduce today's speaker, Dr.C.Y.Seemikeri, sir. Over to Professor Y.B. Gayadhani, sir.
Good morning, all of you. I, Yogesh Gaidani, take this privilege to introduce a distinguished, multifaceted, and versatile personality, Dr. C.Y.Seemikeri, sir, who is also guide and philosopher to me. Sir is currently working as a head of Department of Mechanical Engineering at Government Polytechnic, Nashik, and proud to say I am alumni for the same department. Sir, he has 30 years of UG and 5 years PG experience, and he has worked in a different capacities in government organization as a faculty member, HOD, project officer, rector, and in charge principal at Ratnagiri, Karad, and now at Nashik. Sir has received, this is the one of the remarkable thing, Sir has received Best Teacher Award from Government of Maharashtra in 2013 and from ISTE National Level Award in 2015. Recently, under his leadership, NBA Accreditation of Mechanical Engineering program of 6 years up to 30 June 2025 was received. And I think this is the first and only program accredited for 6 years in Maharashtra state till date. Perhaps in India, it is to be confirmed, but it's one of the remarkable and very important things. Sir has completed his bachelor degree in mechanical engineering from Karnataka University, Dharwad, and masters from Walchand College of Engineering, Sangli, and he has done PhD in mechanical from Dr. Batu Lonere in 2009. He has acquired many additional qualifications. Sir, you have really achieved its different qualification. Even I am not aware or unknown about its full form: DBM, DIT, MBA, LLB, ADC. And being a national merit scholarship holder throughout his education, he stood always in the first merit list throughout the educational career and maintained first class with distinction status. Officially, he has proficiency in 5 languages, and he has undergone variety of trainings, more than 59 weeks at various institutions of repute. And to tell about his research contribution, he has done 79 research papers in reputed international journal and conferences with a citation index of 267. He has also contributed in books and book chapter and a regular reviewer of elsewhere publication as well. And Sir is guiding 5 PhD candidates apart from many undergraduate seminars and projects. He has delivered expert lecture in many STTPs and workshop as a resource person and chair many sessions in international conferences. He has worked as a chip coordinator for many FDPs and workshops. He's also a life member and fellow of many professional bodies like IST, IE, IIP, ISME, and IIE, etc. Sir, there are many things to say about you, but really, our today's speaker has a very good educational as well as professional background. And to tell about Sir, आई नो कि सर जब कहते हैं सर व्यू ऑफ सर टुवर्ड्स लाइफ टुवर्ड्स एजुकेशन एंड क्रिकेट, सर जब बोलते हैं कि क्रिकेट सर मैंने सुना है सर जब पढ़ाते हैं ना तो पढ़ाते वक्त भी सर ऐसे करते हैं, कभी कभी कुछ डिफिकल्ट थिंग्स आती है ना तो लाइफ भी ऐसी है, कभी कभी बॉल बाउंसर भी आता है, कभी कभी बॉल ओवर पिच भी आता है, बट यू हैव टू प्ले, यू हैव टू प्ले एंड यू हैव टू प्ले silently, perfectly, precisely. Sir, thank you, sir, for giving me this opportunity to introduce my teacher. And now I hand over this session straightforward to our today's speaker, Mr. Dr.C.Y.Seemikeri sir. Over to you, sir.
Okay, thank you very much. Dynamic introduction by Professor Gaidani. Thank you very much, sir. I also thank the organizers, Professor Lande sir, Dr. Karanjkar sir, Sanab sir, and principal of the institute, Professor Kadve sir, and then Professor Kalmani sir for giving me the opportunity to share my thoughts on some technology aspects, especially under this FDP, which has been well organized by K.K.Wagh, one of the renowned institute in this region. I also appreciate the contribution of already the eminent speakers last 4 days. I came to know that there were sessions on how to write research papers. That is also done by Professor Karanjkar sir. He happens to be our faculty member of Nashik earlier. Now he's working in Ahmednagar. So it's one of the best, I think, presentation. I think I received feedback also from many best presentation. And apart from that, there was also session on how to conduct research, how to do design of experiments rather. So all these sessions are definitely very useful and handy for our Polytechnic faculty family, so that we are not lagging behind the degree faculty. Usually there is apprehension, there is some negative thinking amongst our faculty that Polytechnic people, no, they lack research, they lack new technologies, they lack new knowledge. They only pursue old knowledge and teach old engineering drawing and all that. So that particular perception has to be changed. And therefore, I appreciate the efforts of all faculty members of K.K.Wagh and others who contributed in this excellent FDP, which has been taken to many other Polytechnic friends across the state and across the country, perhaps because it is a national level FDP. So therefore, I thank the organizer once again before I proceed to my presentation on surface enhancement technologies. Basically, this is a presentation which I have done long back. I got an opportunity to write a book chapter on surface enhancement technology. So therefore, I got an opportunity. So that opportunity by Geo Paulo Devium, editor. So given opportunity to computational methods for optimizing manufacturing technology. Under that, I try to explain how burnishing could be helpful in surface enhancement technology. So before I go to burnishing, I would like to tell you surface enhancement technologies means how you can improve the surface of a particular material or of a particular product or a component which have already undergone some manufacturing process. For example, when you machine a particular surface, if I simply take a mild steel material or maybe a AISI 1045, that is a carbon steel, medium carbon steel. If you machine it, what happens is you'll definitely get the required shape and size and finish, no doubt about it. The people will think that the surface enhancement technologies are only to get the finish, but it's not the right way to think. It's not that only the finish or the shining color, I mean shining nature will help us. During manufacturing processes like machining, welding, etc., what happens is, while removing the material, we are inculcating, we are actually producing certain tensile stresses, quote, tensile stresses. So, because of the chips are coming out of the surface, a lot of heat is generated during the machining process. We are introducing the positive stresses called as tensile stresses, which are harmful to the surface, harmful to the component, which will reduce its strength. Strength component will reduce significantly during many manufacturing techniques like machining, milling, welding, shaping, etc., etc. Thereby, we are not only losing the finish, but also losing the strength of the material. What strength? In terms of the fatigue strength, in terms of creep strength, in terms of hardness, in terms of many such properties, mechanical properties, I would say mechanical properties. It's a big exhaustive list, including certain chemical properties like corrosion resistance, wear resistance, etc. So many tribological properties, I use the word tribological properties, are destroyed during conventional manufacturing processes. So how to restore them? One of the method of restoring, one of the method of enhancing the surface, improving the properties of surface is, example is burnishing. It can be burnishing, it can be short peening, it can be laser peening, it can be rolling, like that. Or it can be even grinding also to some extent. So one can be water peening also, peening. So these are the methodologies which are inculcated in the manufacturing process, not only to get the finish out of that, but also to get required strength and stamina into the component. That is why I thought my research work, whatever I have done long back, has to be shared with my new generation, so that my objective of this particular session is inculcate basic aspects of this particular area, and you all explore certain research possibilities. There are so many research possibilities still inculcated into this particular area. Never any topic ends in research, as we all know. Therefore, this particular area is untouched still in many aspects in Indian scenario. We can trap that, and my new faculty members can definitely start new work in this research area, which I have left long back. Still, people are continuing this research work in many other colleges across the country, across the other country also. So why not the people from our own people of our own district, our own state, can also contribute in this particular research work? With that objective, I thought probably I can share my research work with new potential, the old, this thing, knowledge, old knowledge, rather say old knowledge in a new bottle, or maybe a new bottle with an old knowledge, whatever you call. So I'm going to introduce you, friends. This is outline. My presentation is basically introduction to the LPB, concepts of surface integrity, what is that, motivation and scope. Then scope of LPB, low plasticity burnishing in biomedical applications, which is the new emerging area where perhaps engineering and medical practitioners can definitely share their ideas, do can combine research here. Apart from that, scope of LPB in heavy electrical transmission. So mechanical and electrical people, electronics people can join hands here. So research is no longer a watered compartment where only purely mechanical should do. Research, on the contrary, I would say it is basically embracing many interdisciplinary people into one work, so that really the big outcome can be derived. Review of literature and relevance of the proposed work. I am also giving little bit review how the particular relevance of this area. Then experimental work proposed. What experiments work we can undertake in future if you really enjoy this session and you want to undertake certain experimental work in this area and publish papers. Then certain conclusions and references. So I chalked out my presentation could be around 1 hour, not more than that. Probably you can ask in between some questions also, or after that also I'll give a lot of time to interact. And if you want more information, I have got other presentations also. I would share if you want. The first aspect is what is burnishing. Many of my friends will be already knowing, perhaps even diploma engineer also does know what is burnishing. It is one of the fine finishing operations involving plastic deformation of surface to enhance the surface integrity and functional utility of the component. As I told you, your surface is basically deformed plastically. We are going to deform it. Definitely there is some reduction in size, and the metal is going to be pressed by a tool, and therefore it is undergoing plastic deformation. Thereby the surface layers are basically pressed to enhance the surface integrity. The better word is surface integrity. I'll talk about that. And then functional utility, so that the functional performance would improve. Basically, burnishing is a secondary operation. As I told you, it's not a primary operation. A primary operation will be like turning, milling, shaping, grinding, etc. Even electro-discharge machining is one of the best primary operation. It gives rough surface basically. Electro-discharge machining will give rough surface, welding even. So to enhance the properties, other properties, we go for burnishing as a secondary operation. So therefore, burnishing can be performed either with a ball, a one ball or many balls. So we can use any type of ball. We'll talk about that, what will be the material of the ball, the size of the ball and all that. There are wide variety of ways in which the ball, you can use the ball, or sometimes people will ask, sir, why not roller? Yes, you can use roller also. So ball or roller can be used in burnishing. So depending on that, the burnishing has been classified into many research potential areas like balizing. So balizing means actually you already drilled a hole, you take a ball and press the ball inside the hole, and you remove the ball through that. So thereby the hole particularly drilled will be strengthened, and also the shape of the hole will be perfectly circular. So it's called balizing. So a lot of work is going in Russia still. 25, 30 years back, the work is going on, and still a lot of work is going on still. Balizing is another research area. Then burnishing is one general area. Again, I told you burnishing, vibratory burnishing. If you press that particular ball continuously, it's burnishing. If you have intermittent burnishing, where there will be a little bit of vibrations created, excitation is created for the ball, so that the ball will be continuously with certain amplitude is hammering on the surface. It's called vibratory burnishing. Again, it can be done with certain ball or roller. And once again, you will have ultrasonic burnishing, where you can create ultrasonic waves. It's one of the latest area of research undertaken in America right now, in USA, with Lambda research. Also, the NASA is undertaking such research work, ultrasonic burnishing. A lot of work is going on. Apart from that, now also low plastic burnishing is the state-of-the-art burnishing technology. It's been created again in NASA or Lambda research in 2003. It is patented by Lambda research again in 2005. So low plastic burnishing is a little different from the conventional burnishing. I'll talk about that through my next presentation slides. So that figure shows you that surface of roughness will change the certain microns rough surface into a better finish also. So schematically, this LPB, low plastic burnishing, has been shown. In most of the situations in mechanical burnishing, the ball is being pressed by a mechanical force in terms of using a spring and all that. The beauty of this particular plastic burnishing is the ball is being pressed not by the spring but by the fluid, supporting fluid. That's what it is shown in the screen. So that particular fluid is forced through the tube, and that fluid pressure is applied through a power pack, hydraulic power pack. So I have designed a particular, like actually my research work involves designing the LPB tool. The new LPB tool has been designed long back, and a separate ball is kept and pressurized by the hydraulic fluid, which is called as in our case power pack, hydraulic laboratory power pack. Was utilized to support that particular, so that you can apply uniform pressure. The beauty of the hydraulic systems is usually you can apply very less pressure also, and constant pressure. So that is the beauty. Therefore, I utilized so oil fluid. Perhaps you can utilize it, even you can use air also, pneumatic burnishing tool. You can undertake that. So there's a lot of innovation also one can do. So ball is being pressurized by a certain fluid bearing I have designed, and that is applied on the surface, and the ball will be moving. You can use one ball or more number of balls. I have used only one ball in my case. The ball was moving on the surface with certain feed as what we use in the conventional lathe. So it was used in lathe machine. So slowly the ball was moving, and then whatever tensile stresses were created on the surface because of other machining or maybe whatever other primary manufacturing process was reduced by this particular ball, because you are pressing the ball, you are introducing negative stress, in the sense compressive stress in that. That's why whatever tensile stress was introduced were reduced. They are called as residual compressive stresses. Residual compressive stresses are induced on the surface, thereby the fatigue strength of the component is improved. That's why we are getting the good physical strength, the hardness is going to be improved, the finish is going to be improved, along with that, coupled with certain fatigue strength. So that was the basic schematic diagram of LPB. Lot of innovation still is pending in Indian scenario. When I started my research work in 2003, so I made my one of the beginning. I could face so many problems in this designing. There are so many failures also during this because there is a lot of leakage of the oil on the surface. The pressure was not uniform. So I have written a paper on this one specifically, design aspects of a burnishing tool. It's available in International Journal, Inter Science. It's available in 2006, 7. You can refer to that paper or you can consult me. If you want any help, I am definitely share my help how to design the burnishing tool for different applications. I have done one particular thing. It doesn't mean that I have done the most. Only thing I could not file the patent because I published the paper. After that, I have gone for patenting. The papers are refused because already the information is published, so we cannot patent it. So if you can have your own new design, you can definitely patent it. So this is the basic aspect using a different. So this burnishing is done by now fluid pressure, not by mechanical pressure. That's what it's called low plasticity burnishing tool. Applied pressure of very less, zero point 0.6 megapascal, but 1 megapascal also. So very small pressure has been applied. The beauty of why I also tell you friends, you require little bit lesser pressure on the surface. If you apply more pressure on the on the surface of the component, there will be destruction of the surface. If you have more plasticity means more dangerous. Therefore, my other friend of surface enhancement, that is basically short pinning. In short pinning, if the ball is hammered on the surface, though we are inculcating fatigue strength, but the amount of deformation is very large. Thereby, the word that is being used as cold working. Cold working. I think everybody knows this. Cold work is very large, around 25 to 30% more cold work in other methodologies. Here, cold work is less than 5%. Therefore, the beauty of burnishing the LPB is lesser the cold work, lesser the deformation. Thereby, the component surface will not bounce back. So, during high temperature applications, the residual stresses inculcated in the surface will stay together. It will not relax. In case of burnishing, what happens if you do with lot of intensity of with a lot of hammering takes place on the surface? What happens is because of larger cold work, the residual stress inculcated will relax while the surface of the component exposed to temperature. So that is the beauty. So that a lot of research work is again there. I don't want to in the beginning only give you that dose, but I told you the advantage of low plasticity burnishing against the short pinning or other methodologies which are force applied with more pressure or more intensity. So this is the schematic diagram which I have applied. See, this is the conventional burning tool applied to a lathe machine. So my focus of research that time was, yes, I am a person from Polytechnic background. I'm a person from Ratnagiri, sitting in a corner of Maharashtra where nobody comes there for research work. Nobody goes there for, prefer that place. So I thought, why not we can apply, create certain research, do some research work for our own people, our own public. So the technology which is hi-fi available in America, why can't we apply the technology to my rural area and rural people, small workshops where the technology can be taken from ground level so that they can use it in their conventional machines and enhance the strength of their materials. Why not? I thought. Therefore, I designed this particular tool using my laboratory equipment. Hardly pressure power is applied, and then lathe check was used to hold the job as well just machining. Then the tool is applied directly on the check so that instead of machining, now I am pressing the job with my tool. So the beauty of the technology is rural people, technology to rural man. And just like community polytechnic, I was a project officer for community polytechnic, so I thought I can transfer this technology for my rural mass, for the common man. So right now it's called Unnat Bharat Abhiyan. So that time only I thought 2003, why not such simple technologies, though people say it is used in NASA and all that. I also received a letter from NASA. One Mr. Ramakrishna, the letter is also with me that you are doing wonderful work in this scenario. We want to join hands with you so that the technology can be more technology can be imparted to Indian people. But that time I was not complete my PhD, so my guide written a letter to them. Let him complete first PhD and then we'll think about that. So people want to join hands with you when you make the technology feasible and possible to the common man. That's the beauty. Therefore, friends, I'm requesting you, still those who are want to continue this work, I'm there to support you people. So basic working principle, I told you, smooth rolling ball comes in contact with only the surface being burnished. Nothing more. So that's what they shown. And this project has been done by me and my students, diploma students. No expertise. Experimental work is done as a simple machine. Nothing. Not in IIT Bombay. Only testing consultancy. Testing was done, of course, in IIT. But other experimental work actually, or actual jobs are prepared in our conventional machines only. So just like it is machining, only instead of cutting, we are pressing the metal. So that's what it's shown. Power power pack is being attached to the burnishing tool, and I am just pressing the surface. Thereby, surface is hardened and surface finish is improved. Simple. That's what I want to show. This particular picture depicts that research is not that high tech. People think that research means you require a lot of high tech things, lot of money, lot of expenditure. No, research is you require only innovative mind and hardworking ability. Nothing more than this. Anybody can do research work. So I would like to introduce friends that in my second point, I told what is meant by surface integrity. So a new field. My focus was I am I am actually overemphasized by the one particular paper, a new field engineering surface, engineered surfaces. The word is engineered surface means the surface are engineered. They are doctored, I would say. Doctor means surface is changed. So engineered surface, I have read this paper regarded as one of the effective and economic route to the successful manufacture. In 1998, when I completed my master degree, so I could read this paper. It's available still. Please read this paper. He has written, once you get the surface out of any machining or whatever manufacturing method, so a smart thing you can do is you can engineer the surface, change the properties of surface. So therefore, I inspired by that paper, I concentrated on the surface integrity. So in this context, LPB, the state-of-the-art method of burnishing and a new method of surface enhancement, which reached burnishing to next level. So it's one of the best engineering surfacing methodology, which I am introducing today for burnishing the various surfaces. So surface integrity means what? So the surface basically condition is going to be increased. Basically, is going to change because we are making a lot of alterations, a lot of surface changes. As I earlier mentioned, maybe you are introducing machining or welding, etc. What you are doing is you are inculcating mechanical, metallurgical, chemical, electrical, biological changes to a surface. So therefore, surface alterations are belonging to a surface. So that makes the surface unacceptable. Unacceptable. So you require to recondition the surface, recondition the outer layer only. I'm not changing the internal layer, only the outer layer up to say 100 microns or 1000 microns, 1 mm hardly. That surface properties have to be changed without affecting the internal structure of the material. So surface integrity is a multidisciplinary activity. I told you it's not purely mechanical, so in which you have great impact on the parts. For example, an Inconel material, last point I've shown, 718. It is a material which is used in aeroplane applications. Fatigue limit is high as 540. After gentle grinding, is low as 150. So, so after electrical machining, so the surfaces are different. So the same material, if you have different manufacturing process, the fatigue limit is going to be changed. That is the beauty. It means manufacturing methods have great impact on the fatigue life of the component. Thereby, we need to focus which method I must use for increasing my strength of the component. Or if it's not possible for me, I have to use my EDM only and get the particular shape and size. Yes, use EDM, no doubt. But after that, you go for burnishing or you go for surface enhancement technologies, you can restore the other strengths or the properties that you have lost during the particular process. So the surface topography can change the surface layer characteristics. As I told you, virtually all machining and sub-modification process affect the surface integrity by producing an alternative surface layer or subsurface. Subsurface is changed, and also immediately surface is affected. So the alterations may differ depending upon the nature. In case of LPV process, the topology or surface characteristics are significantly changed, significantly, all mechanical properties. So therefore, it's one of the major innovation in engineering the surfaces. Apart from the conventional burnishing, short peening, lesser peening, oil jet peening, all I mentioned. So LPV process can be tailored. It can be tailored to suit the required applications. You can use it in combination with many other combinations also. So therefore, the LPV is being proved in its worth in last 15-20 years. You can enhance many of the properties which are not achievable by any other surface enhancement techniques. So they involve surface hardness, surface finish, low cycle fatigue and high cycle fatigue. Corrosion, I'll explain difference. What is related by high cycle fatigue and low cycle fatigue? If I take an example, for example, a boiler, if you take, a boiler is subjected to low cycle fatigue because low cycle fatigue, high cycle fatigue. Sorry. If you take a particular boiler right now and heat it, the temperature goes very, very high in thousands of degrees centigrade because the steam that you get is now high pressure steam, high temperature steam. Slowly the machine components undergoing fatigue. Why? It gets heated. It means materials are going to be undergoing creep condition because enlarged material is enlarged, coefficient of linear expansion. And then when you stop the boiler, it starts cooling. So heating and cooling cycles are very slow. That's called low cycle fatigue. The material is subjected to low cycle fatigue. The bolts, nuts, etc., many other materials which are used in boiler are subjected to low cycle fatigue. It's called as failure due to low cycle fatigue. If you have high cycle fatigue, for example, the shafts are to very high speed, more than 3000 RPM. Got it? So because of the high speed, number of revolutions per second, the particular one, if you take one particular point on the surface, it undergoes failure due to number of cycles are high. So high cycle fatigue. So again and again, the particular primary point. Tire, for example, the car tire moving with very high speed, high cycle fatigue. So all this low cycle fatigue, high cycle fatigue are important parameters for any mechanical engineer. Corrosion resistance, the parts which are propeller shafts working in the ship, for example. So that can be enhanced by burnishing. Wear resistance, you know that resistance to wear. If I use the particular shaft after burnishing, its resistance to wear will increase. The life of the component again will increase. Fatigue is different, wear is different. So you can undertake research work on wear also, on resistance also. Out of roundness is going to improve. You know that in metrology quality control, we are going to improve out of roundness of the jobs for proper fitting. So you can increase the geometrical tolerances also. Electrical properties is a new area of research. I have not done anything on that. You can increase the electrical properties. My next presentations will be focused on electrical properties, how we are going to enhance them. Biological properties is a new area of research. That's why I'm talking about that. Biomedical applications. Tensile strength is going to increase. Torsional strength, foreign object damage, like that, so on and so forth. It is not a watertight compartment, so it is a big area of research. So my today's focus will be rather not on my research, but in future research scope, how the burnishing could be useful in electrical applications as well as biomedical applications for my young, bright research scholars of future. So many of these properties are highly desirable in automotive applications, aeronautical applications, marine applications, biomedical applications, heavy electrical applications. Therefore, this particular surface technologies are finding applications in very, very broad areas in hardcore mechanical engineering. So LPB is currently attracting greater attention due to its low cost. Because why low cost? Because you can apply the technology to the simple common layouts and also high strength applicability and suitable to common machine shop. You need not have hi-fi CNC machines and all that. You can have your simple machine shop. You can simply design the tool and apply it to your machine layouts. You can get the results. You can get the benefits out of that. You can encourage your common man of your villages, of your workshops. Boss, only design the tool and apply it and see the results. Many of the small and scale industries around Ratnagiri in 2003-4, I could enrich. I remember the industry names also in Devruk. They could get the benefits. Earlier they challenged, they insulted us. And then they start working on that. Usually there is a lot of resistance in the beginning. People say, what this bloody teacher can tell us. We are industry people, we are having more experience. But when they get the results, definitely they will come to you. That's my earnest request to friends. Work hard, get into the roots of the variabilities. So, in contrast, I told you, if you go for the depth of the compression, it's around 1 mm by LPB. I told you very cold work around 5%, already I mentioned in my earlier talk. Whereas in short pinning, it's around 20 to 70%, 20 to 70%. Therefore, there will be little advantage in certain cases, short pinning. But in most of the applications, short pinning, because cold working, I told you, cold working on the surface can be detrimental effect. Therefore, LPB produces a very less code work, at the same time more residual compressive stresses, whereas the particular short pinning will have more code work around 70%. So if it's less than 20%, definitely short pinning is advisable. I have done a lot of work also on short pinning. I'll share probably in future works. So therefore, LPB is gaining a lot of prominence and becoming a latest useful surface enhancement technology day by day. It is catching the attention of many, many researchers across the globe, not only Indian researchers. So a lot of people are working on LPB right now, even also in Indian scenario, apart from the other country. The scope of research now, my today's focus will be next, the 45 minutes will be on this particular biomedical applications, how it is useful and how electrical. So please listen carefully how we can undertake research work in these two areas. There are many areas, but I'm introducing today's talk only two areas. How it can be beneficial to biomedical applications. The same mechanical engineer is beneficial to a medical field. My daughter also belongs to doctor's family, so she is doing now MD and then into DM neuroscience. So probably I'll be also joining hands with my daughter in further research work. So biomedical manufacturing technologies are achieving very highly visible positions in all manufacturing front lines, especially the implantation, medical implantation, healthcare services, and surgeries especially. So the focus will be on right now medical implantation. Medical implantation, especially nowadays, almost all 50 plus people will have problem of their knees, hip joint, knee joints are being treated. There will be a lot of prosthesis, hip surgeries and knee surgeries, knee replacement, joint joints are replaced. So all these are the common things that nowadays common things available even in Nashik also. There are so many doctors, orthopedicians, they'll recommend the knee joints can be replaced because the patient cannot walk really freely. So without even support, so he cannot stand on his legs. So it is inevitable for all of us to go for certain medical implants. So these medical implant materials are basically, it can be 316L or some other materials or maybe certain composite materials. So they have to be processed. Again, mind friends you, the doctors will definitely implant it, but who will manufacture the materials? Who will manufacture the surfaces? Who will produce the, component? This is you and me who are responsible for the manufacturing aspects of this even medical field. Therefore, we need to know what should be the properties that particular material should have. How must we change it? What surface finish should be there? What material should be there? What component should be there? What material should be there? So all these are the change. It means we need a lot of research work within this area to produce different manufacturing surfaces. Even it can be even dental applications also. Forget about prosthesis, even replacement of teeth also with certain materials, or filling the materials also inside the in between the teeth. In prosthodontics, what we call. So therefore, what happens is, friends, if you are putting a material in the human body, there is very difficult conditions, corrosive environment. There will be corrosive environment because the body, saliva, whatever body is producing, it's basically, it's salty. So therefore, it's a corrosive environment for that material. So therefore, the material which is implanted into the body will not survive for a longer period. The moment you start putting, replace the particular material into the body, in the knees or whatever, in hip, the material starts degrading. Its degradation starts, its failure starts. It's called as fretting damage, called as fretting. So fretting fatigue it's called as. So therefore, we need to control its surface, control its properties as per desire. Therefore, we need to recondition the surface according to the requirements of the patient. Every patient is again unique. You must try to find out what sort of surface finish, what sort of strength is required for the particular job to be implanted. So therefore, cobalt, nickel, chromium alloys, nickel, titanium, etc. Finding applications now in artificial joints, dental implants, bones, plates, staples, even for surgery. I mean, heart patients also, coronary artery. So many materials are being used now in human body for implantation. Therefore, so there will be corrosion resistance, the good surface finish is important, corrosion fatigue, as I told you. So it should be cost effective and also biocompatible. The word I must use is biocompatible. So it should survive that 0.59% saline because it is basically NaCl, generally not conducive for environment for the implants. The moment you start putting the material, so failure starts. Therefore, probably the short pinning and other water pinning, etc., are not suitable here because they're producing inferior tremological properties. Because they may introduce also corrosion, a little bit of corrosion also may be created because of more cold work. Thereby, it is not going to be compatible. It's not very compatible. So probably LPB is best compatible. It's not my research work. Recently, a paper is written from NASA. Even Lambda Research has given that the material which is finished by low plastic burnishing is definitely more compatible than other manufacturing processes for implantation. So therefore, a lot of potential is there for us. So the host tissues or where debris is generated by the body in the joints are going to be very large. After some time, there will be debris inside the body. They will release due to the foreign material. So that would reduce. How to reduce that? It can be done by LPV, by inculcating all these properties, the same component in a holistic way, in an economical manner, without side effects. Very important, friends. Research, it's not my research work. Many of the researchers have given the results from the research papers are putting this particular point. LPB has taken this complex assignment of inculcating many better surface properties by inculcating the various mechanical properties suitable to the patient in a holistic way. Whatever, whether he wants a little bit of strength, okay, more strength, less hardness, or more resistance to corrosion, etc., according to the condition of the patient, according to the condition of the location of the job, without major side effects. I won't say without side effects. There will be certain side effects, obviously, when you implant a material, but less side effects and also economically. And it should be feasible for the patient and doctors to implant. So therefore, what I conclude is from this one is LPB can be definitely very handy and very useful for the doctors and also the patients across the whole country, across the globe, across the whole state in Maharashtra, probably for rural people also, that now the cost of the replacements is very high. If our people, our students can undertake such research works, they can start their small scale industries producing these jobs at lesser price, probably the cost of replacements will go down. So we need to put our mind and hand into it so that we can do a lot of research work on different materials. Probably I'm telling you certain materials. Why not you can come out with new materials and burnish it and say, so this is a better material. So there is never end to any research. So only thing what is lacking is we must take a step forward, take certain risk in investigations, put certain money, time, energy into it. So I just again request all my young friends, researchers of all polytechnics, all degree, even all students who are pursuing diplomas, all to please look into those research areas where there is a lot of potential. So one potential area I have identified. There are many. This is one of the best research areas right now I'm putting before you. The next one is now I'm putting before you next, in fact, 10-15 minutes is on how LPB can be applied for changing the electrical properties. So it can be again useful for the basic consumers as well as the common people, the people of MSCV engineers, and also to all engineers, all of us. So how it could change the transmission? So I'm not I'm not doing any research work on this one right now. My research contribution in this area is again zero. I'm only exploring the possibilities that in future you can take. So I have done a little bit of basic works. I have given little work to my PhD students. So work is going on. As I told you, I am already getting certain PhD work. One of my PhD student is already out. He has completed his PhD, not in burnishing. Of course, he has done his PhD work in some other area. Two of my candidates are doing pursuing work. One is burnishing, another is in friction stir welding, etc. The work is going on. So this work I have not given to anybody still. So electrical power transmission. Friends, we all know that electricity is very scarce in India and it's very costly. That recently, I think it has become a political issue also, that the bills are given to us are very, very high. It's very difficult for the common man to pay these heavy bills as a stretch during lockdown. It means the production of power is very, very high. Manufacturing of electricity is high. And then it's also the transmission. Once you manufacture electricity, then there is distribution, what's called as transmission and distribution. Friends, the losses are around 10 to 15%. We never notice it. Electricity manufactured and it can be used at the source, losses are very less. When you use the lines, transmission lines, see whatever you manufacture, 10, 15%, even more than that. Some people say it is around 20, 30% also. We are losing it just in transmission from one location to other location. Can you imagine? We are transmitting the power from, for example, Nagpur to Nashik, for example, through thermal power plant there, or maybe from Nashik to Mumbai, Nashik to Kolhapur. So situation, how much power we are losing. So no, people are knowing it, a lot of this is going on. But the common man doesn't know the losses are so much that whatever we have produced, we are losing it only in transmission. And now we have to think engineering point of view, how could we reduce it? What are the ways to reduce it so that the manufacturing costs and transmission losses will be less, so that our bills will be less. And ultimately, our customer is benefited. The power is usually transmitted through overhead power wires. You know that overhead conductors are not covered by insulation. You know that they are heavy 33 kV wires. Even more than that, they're coming. Power is coming through very heavy wires. You know that you notice that wires are very heavy and they are actually sagging also. Wires are sagging. The conductor material usually use aluminum, and aluminums are twisted several strands and possibly reinforced with certain steel material so that it won't deflect much. If you use other material, we use aluminum, etc., because they are more conductive. More the conduction, obviously, more the electricity we can transmit, so the lesser the loss. That's why we are using aluminum and copper. Copper is better again, but cost is again high. So the aluminum is preferred, and copper was sometimes used for overhead transmission. But I told you, aluminum is lower in weight to equivalent performance and also cost. We use aluminum. In domestic application inside the house, we use copper because it's very small wires. Ductility is high. Also, higher end applications we use aluminum as the transmitting material. Of course, there are other countries, instead of over-conductive wires, now I think through gases now directly without wires also they are transmitting. But it's a Indian scenario, still we are using this. The origins of the limits. For short line, heating of the conductors, because of the transmission of electricity, obviously there will be lot of transmission losses, and when transmitting the electricity, there will be obviously heating. So you can notice that while transmitting the electricity, TTT, because of temperature, because of the stress, and then because of the heat, the particular material undergo creep. The creep is the biggest failure hurdle there. Creep. I think every mechanical engineer knows it. That is the reason why, because of that, there will be overheating, because too much of current is drawn, conductors are sagging close to the ground. You obviously observe that the whole cables are sagging. They are coming down, touched. They are being applied a lot of tension at the ends. They are pulled. Same time, when you pull it, because there is elongation because of the heat, they're sagging. You know that sagging. And because sagging, because of time, temperature, and stress. TTT, you know that there will be creep, it will be sagging, so they're coming down. The strength is also reduced. At the same time, they're losing the material properties also gets changed. The surface properties will change, inner properties also will change. So electricity transmitted at high voltages reduce energy lost in long distances. So there are a lot of research is going on from electrical research point of view also. What are the parameters? Whether should I transmit with high voltage or with low voltage or to longer distance, etc., etc. There is another. There are other parameters. I'm talking about only mechanical point of view concept, not necessarily electrical concepts. So higher voltage and the current, thus resistive losses in the conductor are, large. Higher the voltage, higher the resistive losses. So people also use this criteria. What? The conductor size, cross-sectional area is another parameter. So got it. So the circular cross-section is circular is better. Usually the people are trying also how to change the cross-sectional area of the material. For example, if you use aluminum, whether I must go for circular cross-section or maybe oval, or why not others. If you go for elliptical or box, they are not suitable because they have such concentration and all that. So therefore, again, it is proved that the circular cross section is better. Again, question is again what should be the size of the component, whether it should 12 mm or to what. Again, it depends on the voltage, etc. So it varies from 12 mm square to 750 mm. So depending on the resistances and current carrying capacity. So thicker wires would lead to relatively small uh, capacity and that skin effect that causes most of the current to flow to surface. What happens is, if you use the bigger wires, usually the current flows. Again, this is going on. How the current flows is through the surface, right? Instead of going to the center point of view, the current flows, most of the surface is being utilized there when the current flows. So high temperature semiconductors are actually promised to revolutionize the power distribution for providing lossless transmission. But in any scenario, this particular high temperature semiconductors are very costly. If you use this one, we can have the lesser loss, but we are not able to use this right now. We are using still the conductors with larger wires with skin effect only. Therefore, the solution existing is right now, how can we change the properties of the surface rather than changing the whole material and going for semiconductors, superconductors. If you go superconductors, probably we are going to have lesser losses. It is a challenge before the power industry. Rather, things are going to change probably in future. But right now, to tackle the situation, we need to go with the situation, and thereby we can change whatever is there. We can change little bit. That wire itself, we can change the properties so that we can restore certain things. So restore certain mechanical things. So looking into the losses, how can you address? We can address the surface of the properties of the conductors are again doctored or they are changed to suit the conditions. What we can do, that's what I mentioned, engineering the surface or doctoring the surface. What we can do little bit so that we can change the properties. It may lead to reduction of diameter of wire. If you reduce the diameter of wire, obviously your uh, wire to weight resistance will increase and also mechanical strength will improve, finish will improve, surface hardness will improve, fatigue, low cycle fatigue, I told you, creep will be also improving. So also it will change in the electrical property. So I won't claim much here that what will change and what will change, etc. Because the research work is still going on. A lot of people are working on that. Both electrical engineers and mechanical engineers are working on that. How the all the electrical properties are going to change. Itself is a basic research of electrical engineers. As being mechanical engineer, we can increase the strength of the material so that we can use the now whatever diameters that we can reduce the diameter so that material can be saved. We can increase the strength of the creep so that the life of the component, life of the wire will improve. The sagging of the wire can be reduced, or we can improve the other hardness. The fatigue strength, low cycle fatigue failure can be reduced. Thereby, a little bit of increasing the conductive property. If you increase a little bit of conductivity, if you get good results, still nothing is much proved. If you could little bit, we can increase conductivity. Definitely, our losses will be less because I told you more the conductivity, more lesser the losses. Like that, we need certain good research results to prove that we can enhance certain electrical properties as well, along with mechanical properties. If you can use such material, you can use such technologies to improve the surfaces. That will be definitely a technology for not for your PhD, but for the country, I would say. Friends, I request you, if you inculcate such basic research works, which is very, very contributing to our Prime Minister's, guidelines to us, what? Self-reliance. So you can have our self-reliance technologies, self-reliance surface enhancement technologies for our future India, self-reliant India. So instead of depending on others, what other countries do it, they will give material, they will give this technology, we will simply copy it. We will collaborate with them, we will go with them. So instead of why not? Why not we, our people can inculcate such technology? Why not we can use such projects for students? Small project works to uni students. You this work. Take the copper wire, do some work on that. What? You just machine it, then burnish it, see what conductivity, how it will change conductivity. Whether it remains same, whether it is going to change. It is a experimental work one. Give another one. Check its fatigue strength. How? Take two, three, give different material to different students as a project work. You turn the material, you take one job, turned job, you by burnishing on the particular job, you short pinning on the other job, like that. You test it for the fatigue failure. Fatigue failure. How? Hold the job in a machine called as fatigue testing machine. I think my friends, do your friends will be knowing fatigue testing machine means RR more type testing machine is available commonly in almost all engineering colleges. May not be in Polytechnic. Hold that job in that particular machine. It's just like lathe. So rotate the job. I don't have that particular fitting, otherwise I would have shown you through a video. I couldn't get enough time to prepare for this actually because yesterday I was in a different meeting. So I'm a little bit explaining here 1 or 2 minutes. Take that job, rotate the job at very high speed. So job will fail, definitely. Use a fatigue testing machine means the job is rotated at high speeds under no load conditions. So it will take, for example, 18 hours, 20 hours. After that, the job will fail, fracture, it will fracture. It undergo necking in the beginning, then it will fail because of the fatigue stress. So take the burnished job, check it. So suppose you say, sir, it will take 18 hours, it's very long time. So what you can do, take the job, load it at the center more, bending, that will cause bending. It will cause bending. Because of the center load, it will cause bending. So rotate that job, it will fail in 1 hour, less than 1 hour, definitely. Because load is applied, under that high load, it is introducing you the two types of loads. One is the compressive load and tensile load. Continuously, the job is creating the fatigue failure. Alternatively, you are creating the bending and compressive stresses. Thereby, the specimen will fail less than 1 hour because high bending stress. High bending stress also fatigue strength is decreased because of the load. So RR Moore type will show that the job has failed in 1 hour. Now apply burnishing or short pinning, whatever, for that aluminum or copper job, whatever. So now you observe that is not going to fail within 1 hour. It will fail after 1.5 hours. Check it. It's my challenge. Do such experimental work. It's what outcome-based learning, what MSBT says. Teach such things. Give your students such jobs, such practicals. Rather than, don't say that research is not required for Polytechnic. Say research is basic aspect for every teacher, our every principal, our every management people will say, why we require research work? Why we require this? But I would request you friends, research is mandatory, research is basic requirement for every teacher to enhance his knowledge. Teachers are basic carriers of knowledge. They should be given chance to do research work. They should be given chance to do practical work. The knowledge should be enhanced. Research is not to get increments. Research is not to get salary hike. It's not to get the post of principal or HOD. It is for the students. It is for the society. It is for the government. It is for the public. So coming back to the point. So I stress that such basic experimental work, when you take a copper material or an aluminum job, you test it for fatigue strength on a RR Moore type material, definitely the strength has increased. It means the fatigue life has increased. Fatigue strength of that particular component has increased. You can check the job, the same job you can check for conductivity, whether changed or not. Let them check, sir, conductivity improved. Or they say, so not changed, let it be, no? Some students will check, sir, corrosion resistance are improved or not. Once it is burnished, another is not burnished. Simple jobs You may not do a lot of research work, but little bit of experimental work will show that, yes, with the help of that, more type, yes, mechanical strength has increased. You can measure its finish. You can measure using metrology laboratory. You can measure its surface finish by telesurf instrument available in almost all laboratories. You can measure its surface hardness. How you measure a surface hardness? By conventional or maybe surface hardness equipments are available. Nearby industries are having that micro hardness tester. Micro hardness tester in HV they will measure. So I have done a lot of research work. Refer to my papers, my contribution here. So how after burnishing the surface hardness has improved and to what depth it has increased. Up to 1 mm depth it is going to increase. So I have already my result publications are presenting this. Fatigue is also I have presented in my, for common material like steel, but not for copper, but not for aluminum. So you can undertake such different materials and check for low cycle fatigue, check for creep, check for corrosion, check for electrical properties, how ductility is going to change, how torsional resistance is going to change, like that. If you give results that, yes, sir, conductor is enhanced 1%, that 1% will reduce your power transmission losses by another 1 or 2%. If everybody is contributing 1%, our GDP will improve, definitely. Our losses will reduce. Our electrical people are benefited. All engineers will come to you, sir, tell this. So therefore, friends, it's not one person's job that only one person can do the change. It's all of us have to cause the change. You have to accept the challenge, accept the new learnings and try to create the change. That is the objective of me to today presenting this particular new innovative chapter before you. It's not the only innovative. There are so many innovative things in the world. But I would say the basic hardcore researcher always focus on basic hardcore research is required for a polytechnic student so that many research opportunity can be explored. Therefore, the enhanced properties in a holistic approach, I use the word holistic approach, will definitely contribute the reduction of cost of manufacturing, installation, maintenance, apart from losses in transmission in many folds. I would say, I won't say definitely, but if you continue the research work and you come out with results, definitely you can give results. Yes, in every area we can contribute this. So I have gone to the review of literature, relevance of the proposed work, review of literature, LPB. Very few experimental studies in this area have been conducted so fast. I told you still 15, 20 years. The studies have been mostly aimed at aerospace materials. I told you, because a lot of research is going on aerospace materials, 7075 T6 is aluminum alloy used in aeroplane applications. Inconel 7-way net is also an aeronautical material. Tungsten alloy, titanium 6Al6V. So such materials have been done through LPV, can be applied for all types of carbon and alloy steels, stainless steels, cast iron, aluminum, titanium. We can apply. Who stopped you? Nickel-based superalloys. You can conduct research work on that. Your paper is published. So we got a lot of scope of applying LPB to different materials also. Forget about the other areas. One same materials can be tested. Further, these studies have been conducted with certain specific objectives under certain experimental conditions and using different machine tools. We can use the machine tools of our own. Why can't we go for CNC machines and tooling? We can go for our own layouts, our own simple lathe machines, or simple machining, milling machine we can have attachment. Why not? That should be our focus. Therefore, I am identifying research potential today to my young budding engineers. Use of LPV in biomedical applications, use of LPV in heavy electrical applications, use of computational methods. Another I am telling you, those who are interested in computer applications are using software for this use of computational methods for analyzing LPV. Why can't you can analyze the LPV itself? Finite element modeling you can do. What are the, or you can go for designing the tool itself, or you can apply LPV for analyzing what are the various parameters affecting the various surface properties, how to control the properties so that I can get the best possible combination to get the required finish, hardness, fatigue, etc., etc., etc. So use of computer software, or you can design your own softwares. Right now, there nothing is available. You have to go for experimental work and produce. Why can't you can have your mathematical modeling on that, so that you can directly mathematical equations are available. Put the required conditions of the parameters and the levels. You can define the outcome of that. So that certain regression models you can prepare, certain mathematical equations you can prepare. So you got lot of potential research is still available, young friends. So you can explore that through this research work. Apart from basic materials, these are the various exploring areas. So in order to achieve this objective, it's necessary to make suitable experimental plan. Without experimental work, nothing can be proved. So you have to have selection of suitable strategy of experimentation. You can use design of experiments here. I think first session already has been taught to you. The experiment accuracy of the experiments again depends on the what type of strategy you followed. Whether you require some pre-experimental planning is required before you go for major experiments. You do some preliminary experiments for your students. You have some project work. Then you can go for major experimental work. So conclusions, I would say today's conclusion is database developed by the experimental analysis computational methods could be very useful to the selection of best possible process parameters and conditions for finishing various biomedical components economically by inculcating the required surface characteristics as per the functionality requirements. Similarly, increasing the efficiency of heavy electrical transmission lines. I mentioned that you can definitely predict what could be the parameters so that my biomedical materials, I told you biomedical materials are many. I won't say only one. So basically, biomedical materials are many. You can use LPV on many materials. You can use LPV in your own way. You can use roller also. You can use different balls combinations. You can use air. You can use fluid power. You can use any way apply on the different materials. You can check for various properties, various parameters. Similarly, you can also inculcate those economically. Then you can check it for that functionality before and after, how the change you could bring about. Also apply on electrical transmission lines. You can go for aluminum materials, copper material, go to the MSCB, get their materials, simple material. You ask them, sir, we will give your material, we will try to burnish it, we will try to pin it, then give you back. You can check the properties, how it will make difference in the efficiency of transmission or efficiency of development of the power, etc. So my references, we have got our reference publications. I have referred that my guide Brahmankar, my co-guide Dr. Professor Mahagaonkar is right now working in Mumbai. We had these papers long back. Jayaraman, I told you this Jayaraman himself, Privi, these people were already done a lot of work. These are the people who interacted with us. These are the people invited us for further research work in Indian conditions. So various publications are available in the net. We are open to you, and you can use these particular publications for enhancing, enriching your knowledge. If you want any discussions, any doubts, you can always meet me. Or if you have any questions right now, basic questions, I have not talked much about the parameters of the process. Lot more information is there, but I thought probably the heavy dose is not required. If you are really interested, go through the basic studies, basic chapters, and then you can definitely discuss with me. So therefore, at the end, I'm just thank a lot one and all. Over burnishing is not at all good. It will lead to over pinning or code work. So I leave it here to the, and also I thank the organizers for giving me this opportunity to peep into the minds of the young researchers, young teachers who would definitely respect my ideas, my thoughts about research. I appeal to all my friends that please undertake research work. Don't bother about whether it is useful to you or not in terms of career. That research work will change the scenario of yourself first, your home, your family, your society, and totally your surroundings and into nation. Undertake research work that will help you to enhance your knowledge, your confidence, your commitment to the society, commitment to the everyone. So with that, I think I will stop my presentation and now leave it to the persons who are audience as well as my friends to ask any questions. Thank you. Any queries, please? Any queries, please? Yes, sir. Any
No,
questions, please now? I think.
thank you very much, sir, for a wonderful session. Now, I request all the participants that The dais is now open for question answer session. You can post your question in the chat box, or you can raise your hand. We can unmute you. Sir, there is a general question that what are the research domains in which as a new researcher can begin his journey in a surface enhancement technology, sir?
Yeah, I think already I have mentioned once. There is infinite openings, I would say. For the newcomers, they feel like there is no opening, but my point of view as a researcher, infinite. Everywhere you can enter. The first entry, as I told you, first entry is you can apply as it is the LPB tool directly to the different materials. First entry is use different materials. Please note down. आता मी मराठीमध्ये सांगू का इंग्लिशमध्ये असू द्या लेट इट बी इन इंग्लिश और मराठीमध्ये स्विच ऑन करू सांगा कम्फर्टेबल कसं असेल
चालेल सर कम्फर्टेबली हो चालेल सर डेफिनेटली
मी सर्वांना सांगतो की आपण सध्या असलेले मटेरियल आपण बदलू शकतो समजा मी आता एखादी वेळ AISI 1045 म्हणजे मी कार्बन स्टील वापरला EN8 वापरले मी फॉर एक्झाम्पल बरं का तुम्ही कोणताही दुसरा मटेरियल वरती LPB टूल वापरू शकता हा एक रिसर्च तुमचा बरोबर का वेगवेगळा मटेरियल वापरला तुमचा रिसर्च चालू झाला एक बरोबर आहे नंबर 2 तुम्ही LPB टूल मी वापरला मागाशी दाखवलं तुम्हाला तर मी बॉल वापरलेले आहे आणि फ्लुइड वापरलेले आहे तुम्ही फ्लुइड पॉवर काढून वेगळं स्प्रिंग वापरला आणि असं दाबलं तुम्ही व्हायब्रेटरी बर्निशिंग केलं झालं तुमचं PhD चालू किंवा तुम्ही म्हटलं सर मी बॉल वापरलं मी रोलर वापरतो 2-3 रोलर वापरतो त्याचं बर्निशिंग करतो येस इट इज इनोव्हेटिव्ह तुम्ही म्हटलं सर मी एक बॉल ऐवजी 10 बॉल वापरतो एक रोज 2 बॉल वापरतो चालेल लाईक दॅट समजलं का टूल डिझाईन वेगळं करतो चालू झालं तुमचं PhD तुम्ही म्हटलं सर तुमचं टूल वापरून मी इलेक्ट्रिकल प्रॉपर्टीज मोजतो दुसऱ्या मटेरियलचं चालेल तुम्ही म्हटलं मी सर बायोमेडिकल मटेरियल्स आहे त्या मटेरियलचा प्रॉपर्टीज मोजतो चालेल कोणता प्रॉपर्टीज मोजतो मगाशी तुम्हाला सांगितलं मी काय मोजलेलं आहे सरफेस फिनिशिंग हार्डनेस आणि फटिग स्ट्रेंथ हे 3 मोजलं मी बरोबर आहे का समोर दिसतो बघा हा फटिगचं असं स्पेसिमन तयार केलं होतं तुम्ही फटिगचं स्पेसिमन आपल्या सगळ्यांना दिसतोय आय एम शेअरिंग इट स्टील या स्पेसिमन मी वापरलं आणि त्याचं फटिग स्ट्रेंथ मोजलं मी तुम्ही वेगळं मटेरियलचं स्पेसिमन तयार करा आणि मोजा याचं फटिग स्ट्रेंथ इथपर्यंत वाढलेलं आहे बरोबर आहे की नाही की मी ते स्पेसिमन असंच तयार करा त्याच्यावर विअर करून बघा विअर स्ट्रेंथ कसं मोजायचं विअर स्ट्रेंथ या याच्यावरती घासायचं आपल्याला एक मशीन असतो वेअर टेस्टिंग मशीन वेअर टेस्टिंग वरती मशीन लावलं की अगोदरचं वजन किती होतं जॉबचं नंतरचं मशीन घासल्यानंतर त्याचं वजन बघायचं किती मटेरियल रिमूव्ह झाला याचं वजन त्याचं वजनचं डिफरन्स काढले की तुम्हाला मटेरियल रिमूव्ह रेट कळेल त्याच्यावरनं आपल्याला कळेल याचं विअर रेट वाढलं का कमी नाही झाला बिफोर बर्निशिंगचा जॉब असेल तर त्याचं विअर जास्त होईल आफ्टर बर्निशिंगचा विअर कमी होईल त्याचा हार्डनेस वाढेल हे पण रिसर्च आहे म्हणजे तुम्हाला कोणत्याही गोष्टीवरती रिसर्चची डायरेक्ट चालू करता येईल फक्त तुम्हाला ह्याचा बेसिक थोडं वाचावं लागेल आता एका लेक्चरमध्ये तुम्हाला बर्निशिंग बद्दल टोटल नॉलेज पूर्ण देऊ शकत नाही मी कारण त्याला कमीत कमी 4-5 तास लागतील आपल्याला ते कसं प्रोसेस आहे काय टूल आहे कसं दाबतो काय करतो सगळं सांगावं लागेल फक्त माझं 1-1.5 तासामध्ये मी असा प्रयत्न केला की याच्यामध्ये भरपूर अपॉर्च्युनिटीज आहे हे सांगायचा प्रयत्न केलेला आहे मी आपल्याला फक्त एक दिशा द्यायचा प्रयत्न केलेला आहे उद्बोधक द्यायचे आणि प्रबोधन द्यायचा प्रयत्न मी केलेला आहे एनी क्वेश्चन्स प्लीज Karanskar sir, any doubts please?
Sir, there is another question that as a if we compare the surface enhancement technologies like lapping, burnishing, can we apply design of experiment for the same?
Yeah, definitely. I have applied DOE. I have applied DOE technique for this one. If you refer my papers, I applied. First of all, I applied full factorial design experiments with replication, triatomization replication. 32 experiments I have done on this one. Without design of experiments, nobody will accept your paper in journal, sir. Huh? So then I have also applied how slowly Taguchi techniques also. So you can apply RSM also, surface response methodology. Everybody as a researcher has to apply design of experiment techniques to validate the results. Then only results are validated and paper will be accepted. I have done a lot on that, but people still can continue new methodologies. I told you, computational methods also you can apply. You can use the softwares also, like Minitab you can apply, or any other softwares you can use. For example, Professor Pawar from K.K.Wagh, Professor Dr. Pawar, he has already used many techniques like I think it is ABC analysis or artificial B colony techniques, ABC, right? B colony techniques, etc. You can use them. Yes, please. Please come on. Don't hesitate. मी मराठीमध्ये पण आरामात तुम्हाला तुमचं उत्तर देऊ शकतो. तुमच्या मनातल्या शंका मी शॉर्ट पिनिंग पण आपल्याला चांगला मेथड आहे. त्याच्यामध्ये माझा 2-3 एमटेक विद्यार्थ्यांनी काम केलेलं आहे. एस्पेशली पुणेमध्ये भारत फोर्जमध्ये माझा असा एक पेपर आहे. भारत फोर्जमध्ये कनेक्टिंग रॉड्सवरती ते ॲक्च्युली ग्राइंडिंग करत होते आणि एक एमटेक प्रोजेक्ट त्याच्यामध्ये केल्यानंतर द स्विच ऑन फ्रॉम ग्राइंडिंग टू नाव शॉर्ट पिनिंग. लक्षात आलं की शॉर्ट पिनिंगमुळे खूप स्ट्रेंथ चांगला मिळतो. त्याचं लाईफ वाढलेलं आहे. ते स्विच ऑन फ्रॉम ग्राइंडिंग न करता ते शॉर्ट पिनिंगवर स्विच ऑन झालेले आहे. दे आर युझिंग नाव भारत फोर्ज जाऊन चौकशी करा. दे आर युझिंग नाव कनेक्टिंग रॉडचं बर्निशिंग शॉर्ट पिनिंग करतात सध्या. दे आर युझिंग दी सरफेस एनहान्समेंट टेक्नॉलॉजी. आणि 2015-16 मध्ये त्याच्यावरती एमटेकचं थिसिस आहे कराडमध्ये. गव्हर्नमेंट इंजिनिअरिंग कॉलेज कराडमध्ये थिसिस आहे. माय स्टुडंट हॅज डन इट. बोला.
Sir, there is another question from Firoz Amin sir. That sir, please suggest research scope in IC engine.
IC engine. Hello.
Yes sir. Yes sir. There is a question from Firoz Amin sir. Please suggest research scope in IC engine sir.
त्यांच्यात फक्त त्याच्यामध्येच पाहिजे का? ही थर्मल पर्सन.
येस सर.
आय थिंक ही इज ऑडिबल. त्यांना ऐकू, मी काय बोलतो त्यांना ऐकू होतं ना? तुमच्या समोरच आहे का? ओके, मी बोलतो. बघा, आयसी इंजिन आता कोणत्याही क्षेत्रामध्ये आपण रिसर्च पोटेन्शियल काढू शकतो. एक चांगला रिसर्चर असतो तो कोणताही ठिकाणी कोणताही एरियामध्ये रिसर्च आपण करू शकतो. असा कुठलाही एरिया नाही तिथं रिसर्च होऊ शकत नाही. किंवा काही लोक म्हणतात की नाही तिथं भरपूर रिसर्च झालेले आहे, तिथं स्कोप नाही. मी अशातला रिसर्चर नाहीये. तुम्ही कोणताही एरिया सांगा, तिथे शोधून काढून रिसर्च करू आपण. आता बेसिक रिसर्च एरियाज, आता थर्मलचा एरिया आहे त्याच्यामध्ये सुद्धा आपण बेसिकली इंजिनिअरिंग मेकॅनिकलमध्ये 3 आहे. वन इज थर्मल साइड, सेकंड इज मॅन्युफॅक्चरिंग, थर्ड वन इज डिझाईन. पण ॲज अ रिसर्चर कोणीही माणसं कुठेही आपण एरियामध्ये इंटर करू शकतो. कारण आय टोल्ड यू रिसर्च इज इंटरडिसिप्लिनरी. बेसिकली आपल्याला मनामध्ये असं शंका काढून टाकायचं की मी मॅन्युफॅक्चरिंगमध्ये PhD केलं, मी डिझाईनमध्ये केलं, मी अमुकमध्ये केलं. नाही, आपण इंजिनिअरिंगमध्ये PhD केलेलं आहे, मेकॅनिकल इंजिनिअरिंगमध्ये. सो ते लक्षात ठेवायचं आपल्याला. नाव आता आयसी इंजिन म्हटल्यानंतर आयसी इंजिनमध्ये परत आपल्याला प्रश्न आला की SI इंजिनमध्ये का CI इंजिनमध्ये. सो फॉर एक्झाम्पल इफ आय टेक अगेन आय डोंट नो, म्हणून म्हटलं त्या समोर असलं की आपण एरियाज इव्हॉल्व करू शकतो आपण. बिकॉज एसी इंजिन इट सेल्फ इज अ वन ब्रॉड एरिया. एक समुद्र आहे, त्या समुद्रामध्ये आपण शोधत जायचं. त्या याच्यामध्ये आपण थर्मलमध्येच करायचं का, मॅन्युफॅक्चरिंगमध्येच करायचं का, त्या आयसी इंजिनमध्ये किंवा डिझाईनमध्ये करायचं का. अगेन देर इज अ चॉईस ऑफ द रिसर्चर. आता तुम्हाला थर्मल पॉईंट ऑफ व्ह्यू पहिल्यांदा मी ह्याच्यामध्ये सांगतो तुम्हाला. फॉर एक्झाम्पल मॅन्युफॅक्चरिंग पॉईंट ऑफ व्ह्यू सांगतो. सपोज आयसी इंजिनमध्ये तुम्हाला कंटिन्युअसली आयसी इंजिन इज वर्किंग and there is definitely wear of the material. Continuously wear होत असतात parts आपला. Maybe it can be connecting rod, it can be piston pin or piston, or maybe a crankshaft undergoing continuous wear because of high temperature. You know that it undergoing wear. So what is the wear factor? how much wear coefficient. Can I reduce that wear? How can I reduce my wear in the IC engine? So wear debris analysis can be one area. Wear debris. So wear किती होतो? You can collect the wear sample of the lubricant, for example. त्या IC engine मध्ये आपला खाली केस असतो की नाही, तिथलं ऑइल आपण काढून पार्टिकल्स आपण सेपरेट करून किती वेअर झालेले आहे हे काढू शकतो आपण. मग ते वेअर कमी करण्यासाठी मला काय करावं लागेल, कोणता बदल करावा लागेल प्रॉपर्टीज मध्ये किंवा मटेरियलमध्ये. यू कॅन डू रिसर्च लाईक दॅट. किंवा टेम्परेचर वाढतोय, कुलिंग होत नाही. सो तुम्हाला तसं जसं आपण डोकं घुसवतो, हंड्रेड्स ऑफ थिंग्स वी कॅन डू रिसर्च वर्क इन एन आयसी इंजिन. असं म्हणजे समोर बसून आपल्याला चर्चा करावं लागेल इन दॅट एरिया. कमीत कमी 50 ते 100 रिसर्च ऑपॉर्च्युनिटीज एकच इंजिनमध्ये मी काढून आपल्याला देऊ शकतो समोर. आपण बसून चर्चा करूया. एक्झाम्पल, आय टोल्ड एक्झाम्पल लाईक दॅट. कोणत्याही एरियामध्ये आपण एक्सप्लोर करू शकतो. प्लीज बोला. Any other questions, please? Yes? I think questions are over now, I think. Huh?
Yes, sir.
Sir.
Yes, sir. We move to the next session of the program. Next point.
Okay.
Okay.
So, if you want more information, I can give you if you want more information. Or if you are satisfied. Huh? Okay.
Yes, sir. The questions are question and question session is over, sir. Now.
Okay.
Now it's we are moving towards the last point of our today's session, that is vote of thanks. Now I'll request Professor A.T. Karanjkar sir, coordinator regular shift Department of Mechanical Engineering, K.K.Wagh Polytechnic, Nashik, to propose vote of thanks. Over to Karanjkar sir.
Thank you, sir. Sir, it was a very wonderful session. Thank you, Seemikeri sir. On behalf of management, principal, and H.O.D of Mechanical, I, Anil Karanjkar, thank you for delivering a wonderful, knowledgeable, and interesting expert talk. The subject of talk was surface enhancement technology. Sir, you mentioned LPB, that's low plasticity varnishing. So it was a very wonderful session. Thank you, sir. I also thank to all the participants and for their patient listening. And also, I also thank their HOD and principal of respective polytechnics to allow their faculty to release for the FDP. I also thank you to organizing committee and coordinates of this FDP for smooth conduction of the program. Sir, your knowledge in the field of surface enhanced technology always beneficial us, the use of LPB, and you always focus or ask faculty to work on the research area.
Yes, sir. Yes, sir.
Your best statement was research is the basic aspects of for every teacher. And
every teacher, yeah.
The knowledge. You also mentioned some of the LPB techniques in the biomedical components also.
Yes, sir.
So I ask all the faculty participants that tomorrow we have also last session on the topic of modeling of mechanical system by Pritam S. Kalos, MIT COE, Alandi, Pune. Okay, so I once again thank you, Seemikeri sir, for delivering a very wonderful and nice session.
Thank you very much, sir. Thank you.
So, would you like to contribute something more?
No, if any queries are there, otherwise actually a lot of material is with me, but I thought probably people will get bored, no, because of the, they must be interested to ask questions or interact. That is better. माझ्या परिणाम सांगितलं त्याला त्या एरियामध्ये आवड पाहिजे.
Yes, sir. Yes, sir.
मला दिवसभर मी रस्त्यावर बोलू शकतो परंतु तो एरिया नवीन असल्यामुळे त्याला कंटाळ येऊ नये म्हणून मी शॉर्ट मध्ये त्याच्याबद्दल माहिती दिलेली आहे.
सर सेमीकरी सर,
हा
स्पेशल थँक्स टू.
हा बोला सर, बोला.
हा काही नाही सर, स्पेशल थँक्स तुमच्यासाठी. आज जरा मीटिंग असल्यामुळे मी गेलो होतो, मी परत आलो होता.
अरे थँक्यू सर. मी फार डोस दिलेले नाही त्यांना, 1 तास 1.25 तासाचा 1.5 तासाचा डोस दिलेला आहे.
तुमचं सेशन चांगलंच झालं, काही अडचणच नाहीये.
कारण मी विचार केला की 2-2 तास म्हणजे कसं होतं, टेक्निकल सेशन त्यांना कंटाळपणा येईल, थोडंसं ऐकायला पण कंटाळा येईल.
नाही नाही
म्हणून मी शॉर्ट बट स्वीट थोडंसं त्यांना रिसर्च पर्स्पेक्टिव्ह बद्दल म्हणजे कसं उपयोग होईल त्यांना पुढं टीचरला मी सांगायचा प्रयत्न केला, आणि त्यांना प्रत्येक टीचरला रिसर्चची गरज आहे हे त्यांना मी समजून सांगायचा प्रयत्न केला. ॲट द सेम टाइम या एरियामध्ये कोणत्या अपॉर्च्युनिटीज आहे, एवढंच नव्हे तुम्हाला कुठल्याही क्षेत्रामध्ये अपॉर्च्युनिटीज आहे सांगायचा प्रयत्न केला मी त्यांना.
छान सर, सगळ्यांनी म्हणजे एन्जॉय केलेला आहे.
ओके, थँक्यू सर.
थँक्यू सर, थँक्यू.
ओके, थँक्यू. आणि कोणत्याही कारणामध्ये दे कॅन ऑलवेज मीट मी, डिस्कस, सेंड मी माझा ईमेल दिलेला आहे, फोन आहे, ऑलवेज दे कॅन कॉल मी, केव्हाही ते बोलू शकता, माझ्याशी चर्चा करू शकता. फक्त LPB नाही, कोणताही रिसर्च एरियामध्ये त्याला डोक्यामध्ये लोकांना डोक्यामध्ये असतं की मॅन्युफॅक्चरिंग माणूस, असं नाहीये. रिसर्चर म्हणजे तो सगळ्या फील्डमध्ये असतो, डिझाईन असो किंवा थर्मल, अशा लोक सुद्धा मला भेटून चर्चा करू शकता. आपलं शेअरिंग ऑफ नॉलेज व्हायला पाहिजे, हे फार महत्वाचं आहे. एकमेकांना आपण शिकत असतो. मी सुद्धा अजून विद्यार्थी आहे, मी स्टुडंट ऑफ इंजिनिअरिंग, अजूनही मी विद्यार्थी आहे असं मी समजतो.
बरोबर आहे, बरोबर.
PhD इज लायसन्स गिवन टू यू फॉर डुईंग फर्दर रिसर्च वर्क.
बरोबर.
इट इज नॉट द अल्टिमेट टार्गेट. ओके. लाईफलॉंग लर्निंग इज माय मिशन. LQ, लाईफलॉंग लर्निंग.
बरोबर आहे.
ओके सर.
चालेल सर. ओके.
थँक्यू व्हेरी मच फॉर गिव्हिंग मी अपॉर्च्युनिटी. धन्यवाद सर. थँक्यू.
थँक्यू सर.
आता मी डिस्कस करू ना सर, मी बाहेर पडू का?
ओके सर. ओके.
थँक्यू व्हेरी मच. ओके, थँक्यू.
Set to click for the feedback link. Complete that feedback form of today's expert lecture. Feedback link is also posted on the WhatsApp group as well as on the Telegram group. So please fill the feedback for today's expert talk. Now we will end the session. Thank you. Thank you all.